This time we have a roof. We have a roof that's rectangular, and assume that the length of the roof happens to be given as 10 meters. The longer side is 10 meters. This side is 10 meters. This side right here happens to be 10 meters. And then the short side, the width, is equivalent to 9.0 meters. And so the roof itself is supported by columns, and these columns are spread out. So these columns are completely spread out, and each one of them is a 2x4. Each one of these columns is what we call a 2x4, but that simply means that they happen to be 4 centimeters by 9 centimeters. We can always transform these units into meters right away by saying if this is 4 centimeters, we multiply it by 1 over 100 centimeters, and then this one gives me 0.04 meters, and the same thing is going to happen to the second unit, where we take the 9 centimeters and multiply it by 1 meter over 100 centimeters, a unit conversion, and that gives us 0.09 meters. So that's the information we're given. And the other piece of information is that the safety factor for each one of these columns is 12 units. And the weight itself, or the mass itself of the roof, M, is equivalent to 13,600 kilograms. That's pretty heavy. So given that piece of information, we want to find the number of supports. So N, how many supports are these if we count them spread out? That's the first thing we want to find out. And then the second thing we need to find out is this gap right here in between the supports. So, we can call that gap, we can call it X. So those are the two pieces of information we're looking for. If we're going to find the number of supports, we use N is equivalent to Wn, capital N, of A times sigma C, and we need to define all these units. W is the weight of the roof, mg. N is 12, that's the safety factor. And then the area A is the area of the supports. Remember, each one of them has a length of 4 centimeters and a width of 9 centimeters. So that area in meters squared will be 0.04 meters times 0.09 meters. That's the area of itself. And we also have the compressive force. This is the weight. Don't forget the safety factor is 12. And then A is the area of each one of the columns. If you look at the columns from the top, then this one, the sigma C, is the compressive force. okay, compressive force, which is 35 times 10 to the 6th Newton per meter squared. So these are wooden columns, and that's the compressive force. Just remember, these are vertical wooden columns. That's the information we're given right there. And so in the next page, we'll go ahead and compute the number of columns given all these units. So 13,600 kilograms, that's the weight. We have to multiply that by the acceleration due to gravity, 9.8 meters per second squared. And then we also have to multiply that by 12, which is this safety factor, divided by the area, the length, and the width, 0.04 meters times 0.09 meters. And finally, by the compressive force, which is 35 times 10 to the 6 Newton per meter squared. So you can see the newtons will cancel out with the kilogram meters per second squared, and then the meters squared will cancel out with these 2 meters, and we're going to have a clean number of units, which happens to be n equivalent to 12. That's the number of units. The next thing we're looking at is if one side is 10 meters and we have 2 sides which are 10 meters. Then we split, we have 12 columns, so each side is going to have 6 columns. 1, 2, 3, 4, 5, and 6. And that simply means that we have 5 gaps in between. And so each one of them has a distance of x. So if we want to find x, we have to take the length 10 meters, the span between the 2 extreme columns, this column and the first column and the last column, and then we want to divide it by the 5 spaces, because we have 1, 2, 3, 4, 5 spaces, and that's going to give us 2 meters between each one of the spaces. So x has to equal 2 meters. So again, just to recap on the problem, we had a roof with a mass of 13,600 kilograms. The safety factor for these columns was given as 12. Each one of them has a width of 0.04 meters and a length of 0.09 meters. The compressive force, remember, if you have a column and you're applying a force on it, it's going to resist, and that resistance or the force that it can take is sigma c, which is the compressive force, happening to be 35 times 10 to the 6 Newton per meter squared. So applying those variables in the formula, including the area of the column, we end up getting 12 columns. And also we can define x as the gap between 2 successive columns, and since we have 5 spaces in between, we have to divide the total length by the 5 spaces, and that gives us 2 meters. Hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks. Bye.